Hello and welcome to the Bearded Mathman's YouTube channel. Hey, in this video, what we're going to be talking about, the basics of trigonometry. We're going to be talking about trigonometry in a way that you can, of course, get through a trig class well, but so that you're also prepared to handle those tricky things that come up in future classes like calculus and all those other kinds of things. So we're going to be talking about what trigonometry is, how to read it, where it comes from, how it's useful, and get you started. So this is going to be the first video in a series that covers all of the things you need to know in trigonometry. This is perhaps the most important one. So trigonometry, what it really is it's the study of the relationship between angles and sides of triangles. And it is older than algebra and calculus combined. So what we end up doing is we end up setting up ratios and we end up compressing some ideas that allow us to, solve some really far-reaching problems. Even though it's that old, it's still super important, still relevant today. And so I'd like to share with you why that is. So before we begin, do you know what an angle is? Because one of the key things we deal with in trigonometry are angles. A lot of the time, something that's so basic and obvious like an angle, something we don't really understand. Well, what an angle is, it's a measurement of rotation. So if we started with a center of rotation like this right here, and we were facing, say, directly to the right, so that would be our starting direction, and we rotated counterclockwise this far, well, then our ending direction would be there. This rotation is what angles measure. Now, if we started on this first line somewhere like this, and we traveled all the way over here, our distance would not be as great as if we started from here to here. But angles don't measure distance, they measure rotation. And so that's a key idea, it's a key concept, and it's something that people often misunderstand. Now in trig, there are two ways we measure angles. There's two units of measure. Just like in measuring a distance, you could measure in centimeters or you could measure in inches. Well, we have degrees, we have radians. You're probably already familiar with degrees. We'll get into radians in another video, but not for now. So let's go ahead and get started with some basic ways that trig is used. Trig is used to measure things at a distance. When you can't physically measure something by, putting a tape measure or visually seeing it and having a way to measure directly with like a sonar or something like that with a laser, we can actually measure the angles and we can measure one distance and we can then know through similar triangles how tall or far away something is. So it's something that's still used today. Now, the language that's used for trigonometry today, it's all function notation. So if we remember, with a function, you have an input. That is the thing that goes inside the parentheses. You have the name of the function, and then you have the output, right? And then with functions, you also have inverse functions. And what inverse functions do is, in essence, they switch the input and the output. So if you have a function whose input is A and the output's B, and you do the inverse function, well, then if the inverse function has an input of B, the output would be A. And that's how they're related. So those are some key things that you have to remember. We're going to address those as we go through, but that's a really big idea, is that when we're dealing with functions, with trigonometry, they're trigonometric functions. Now, here are the three basic starting points, the three basic starting trigonometric functions. There's sine, cosine, and tangent. Now, the input for these is an acute angle from a right triangle. And trig goes way beyond right triangles, but to start with, that's where we begin. Sine, cosine, and tangent have inputs that are acute angles initially. And the outputs, well, those are going to be the ratio of sides from the triangle that those angles come from. Now let's talk about some definitions, right? When we write sine, cosine, and tangent, we don't actually write out the whole word because, mathematicians, we don't like a whole bunch of letters. So we use sine is S-I-N, cosine is C-O-S, and tangent is T-A-N. However, if you say sin, cos, and tan, people might not know that you might know what you're saying. So sine, cosine, and tangent. Now, the letter that we're going to use for our variable, it's called theta. It's kind of a pushed over circle with a slanty line right through the middle. That's called theta, and that's the variable we're going to use. Now, let's go ahead and define our three trigonometric functions. Sine is defined as the opposite side divided by the hypotenuse. So if I had a right triangle and I had an angle right here, The opposite side divided by the hypotenuse is how we define the function sine. Now, opposite means far away from. Adjacent means next to. Cosine is adjacent divided by hypotenuse. So if this was our angle right here, the adjacent side is here underneath, and the hypotenuse, well, is fixed. It's the hypotenuse. So cosine is the adjacent length divided by the hypotenuse. So there's not like a mathematical procedure that you use to figure out what the relationship is. They're defined through exploration. We already know what all these values are, but this allows us to set up to do the process of setting up similar triangles without actually having to go through all of the work of setting up the ratios and all of those kinds of things. Now, tangent is opposite over adjacent. So if we had this angle, then tangent would be the opposite side over the adjacent side. And adjacent means next to, opposite means far away from. So the hypotenuse and the adjacent side, they actually create the angle. The measure of rotation could be considered starting on the adjacent side and rotating to the hypotenuse. Now let's go ahead and throw some numbers in here and see how this works, right? The sine of this angle would be opposite over hypotenuse, so that would be 4 over 5. Whereas the cosine would be adjacent over hypotenuse, and that's 3 over 5. And tangent is opposite over adjacent, so that's 4 over 3. Now these are functions that you have to know, you have to understand. You cannot mix these up. If you need to get a tattoo of it so you remember, then that's maybe what you should do. Maybe there's a less invasive way. Maybe you remembering SOHCAHTOA would help you. So sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the TOA, the tangent, is opposite over adjacent. Now the way I learned it was Oscar had a heap of apples, and it was sine, cosine, tangent. So SOHCAHTOA is the same kind of idea, but there are lots of ways to help you remember this. Doesn't really matter what way you use, but you've got to remember how sine, cosine, and tangent are defined. So the input is an angle, output is a ratio of sides. All right, now let's go ahead and take a look at what would happen if we had the same triangle, but we were using the other angle, right? So if we were using this angle, what ends up happening is the sides don't change, but the relationship between the sides and the angle changes. Because in our first example, the opposite of theta, the side opposite of our angle theta, was 4. Now, the side that's opposite of our angle theta is 3. And so sine is opposite over hypotenuse, so that's going to be 3/5. And cosine is going to be 4/5. It's adjacent over hypotenuse. And the tangent will be 3/4. So you see, opposite and adjacent are not fixed sides. The hypotenuse is a fixed side. It's the longest side, and it is opposite of the 90-degree angle. But opposite and adjacent sides are relative to the angle that we're talking about. So let's talk about the inverse trigonometric functions. Because our trig functions, sine, cosine, and tangent, they have an input that's an angle. That means you have to know the angle, and then you can figure out one of the sides. That's how these functions are used. So if we know the angle and perhaps we know the hypotenuse, but we don't know the opposite side of that angle, we could use sine to do that. However, if we wanted to find an angle given the sides, we would have to use the inverse function. Now this isn't a great definition, but it gives us a working idea of how inverse functions work. And I don't want to chase inverse functions and function notation all the way through in this video. We just want enough to be able to work with the trigonometric function. So this inverse of sine, that's not a negative exponent, it's a notation that means inverse function, is called arcsine. Arcsine has an input that's the ratio of the opposite side and the hypotenuse, and the output is the angle. So if you knew the side length of the opposite side and the hypotenuse, you could use this function to figure out the angle. Now, if you knew the adjacent side but not the opposite side and you wanted to find the angle, well, you could use arccosine. And arctangent, exactly the same thing. Tangent has an input that's an angle. The output is the ratio of the sides. So arctangent, the input's the ratio of sides, and the output is the angle. So the thing here that people always seem to mess up is if they wanted to solve for theta, well, a lot of times they try to divide as if this sign is multiplying, but that's not what this means at all. This is the name of the function and this is the input. The only way you can solve for the angle is if you use the inverse function. And that's arcsine, arccosine, and arctangent. Let's see an example. So we had a triangle like this. It was a right triangle, hypotenuse of 6. We don't know the legs. We don't know the distance of A or B, but we're going to use cosine to find the value of B. So cosine of 38 degrees is going to be B divided by 6. Adjacent is B. The hypotenuse is 6. We can plug that into a calculator, correct to 3 significant figures. We get 4.73. Who knows what the units are, right? So the side of B would be 4.73 centimeters or whatever. Now, if we wanted to use this to find the value of A, well, we could use tangent, but since we figured this out, we may have made a mistake. So it's best to use what we've been given. So using sine would be smarter. A is opposite of the angle. It's 38 degrees. So if we plug that in, sine of 38 degrees would be A divided by 6. Multiply both sides by 6. Plug it into a calculator. Correct to 3 places, you get correct to 3 significant figures, you get 3.69. So A would be 3.69, whatever the units are. Now, we know that angle's 38 degrees because we started with 38 degrees. But what if you were given a problem like this and you didn't know what the angle was? Well, here you would have to use arcsine or arccosine or arctangent. So if we were going to use arcsine to find out the value of this angle, well, our input would be the ratio of the opposite over the hypotenuse. And our output would be the angle. We'd use a calculator to do this because we don't know the properties of this kind of triangle off the top of our head. We're going to see in a future video some situations where you don't have to use a calculator, where you can figure out what the angles are because, well, we're going to explore 2 special right triangles. Anyway, you plug this into a calculator, you're going to get 38 degrees. If you used arccosine, well, that would be the adjacent to this angle is 4.73 divided by the hypotenuse of 6. And if you used arctangent, it would be opposite over adjacent. So that's going to be arctangent of the input would be 3.69 divided by 4.73. That's opposite over adjacent. You plug that into a calculator, no matter what, you're going to get 38 degrees. They're all around 37.96. They're a little different because we rounded these, but that's how it works. So here's the idea. You need to understand how trigonometric functions can be used to find parts of a triangle, right? So you can use sine, cosine, and tangent if you know the angle and you know one side. The thing you have to be careful of is you have to be careful that you identify opposite and adjacent for what they are. Those are not fixed sides. They're relative to the angle. An adjacent side and the hypotenuse make the angle, whereas the opposite side is away from. It's not a side of the angle. It's away from it. Now, you also need to understand how arcsine and sine are different. Same with arccosine, cosine, arctangent, and tangent. Arccosine can be used to find the measurement of an angle. Arcsine has an input that's a ratio of sides, and the output is an angle. And so we can use arcsine to solve for an angle. Whereas sine, we know the angle, we don't know one of the sides, so we can plug the angle in and set up that function and solve to find a side. That's how they're different. Now, the reason that the hypotenuse is not ever considered opposite, well, is because, as you're going to see in a future video, the angle that's opposite of the side that's the hypotenuse is 90 degrees, and the sine, cosine, and tangent of 90 degrees are well defined. It doesn't matter how big the triangle is. The hypotenuse is fixed. It's not going to be considered opposite. It's not going to be considered adjacent. It's going to be just the hypotenuse, and it's going to stay the same. Now, you need to practice some things. You need to challenge your understanding. So I've got a series of questions right here that you can see on the screen. You can go to my website, thebeardedmathman.com. I'll put a link in the description below. You can go to a page that will walk you through all of this. It'll have some notes for you to read, some problems to practice, and a printable version of this that you can download and try on your own. And you can leave me some questions in the comments there. You can leave me a comment down below. You can ask me questions in the comments below. I'd love to hear from you. Anyway, I hope this has been helpful. It is a super, super important set of information because it helps define what trigonometry is, how it works, and it's going to be something you take with you as you move forward. So anyway, give me a thumbs up if you like it. Click subscribe, share it. Until next time, hope you have a great day.